In this video, I want to go over elasticity of demand. Uh, Two aspects, as I said, of this video is just to kind of give an overview. I know many of you have had our Econ 210 microeconomics, so this will be an overview. So I'm not going to spend a lot of time on it, but I just want to point out several things dealing with this economic concept. And then I want to look at an application, and with that application, I want to demonstrate the formula or equation that you will use this week for the assignment that I have posted. So, in regard to elasticity of demand, there's a good exhibitor table, as I've identified here, 4.7, that looks at elasticity and total revenues over on page 115 for you to review. Now, keep in mind, when we look at elasticity of demand, anytime the elasticity of demand coefficient is greater than 1, we would say the elasticity is highly elastic. Highly elastic. That simply means that if we have an increase, if something is elastic, and I'll look at some examples below, but if a product is elastic, whereby its coefficient, as I just mentioned, is more than 1, that simply means that if we have an increase in price, what's going to happen to total revenues will decline. And that's one of the reasons why I pointed out on page 115. If our elasticity of coefficient is less than 1, we would consider that demand to be inelastic. And that simply means the reverse, i.e., if something is inelastic, a change in price is not going to have a very severe decrease in the quantity demanded. Or, in other words, less than 1, if I increase price, guess what? My total revenues will go up. So therefore, in economics, when we're looking at demand, we know the law of demand. There's an inverse relationship. But just because we have an inverse relationship in our demand curve, it doesn't mean that if I increase price, my quantity demanded will be totally offset by that increase in price. So what could happen if my elasticity of demand is less than 1, right? If I have an increase in price, or if my percentage change in my price, what will happen is that percentage change in quantity demanded will be less. Guess what? My total revenues will go up. So that's why one of the reasons, just review the table on page 115 will help you to understand. So one of the things we want to know, as I pointed out here, let's see, price elasticity demand is the percentage change in quantity demanded divided by the percentage change in price. As I pointed out, there's an equation that I use and I want you to use for this week's assignment over elasticity of demand. Coming down here, as I already pointed out, when the price elasticity demand is greater than 1, the product is said to have an elastic demand. So going back to that demand curve, certain parts of that demand curve will be, guess what, inelastic, and certain parts of that demand curve will be elastic. So it's very, very important from the standpoint of a seller, manufacturer, to kind of know where our pricing relationship is in regard to that portion of the demand curve that's elastic or inelastic. Let's come down here to some examples that I have. One thing is price elasticity demand. Okay, let's look at inelastic. I think when we look at prescriptions, That's less than 1 at 0.3. So that tells us that, once again, if I increase price, guess what? It's not going to have an adverse impact on total revenues. Matter of fact, total revenues will probably go up. I need those prescriptions, kind of life and death type of situations. Gasoline, okay, is inelastic. Guess what? I got to keep driving. I got to drive to work. I got to drive to school. So if my price goes up, I'm probably not going to curtail my driving habits that much. Medical care would be the same, as I made mention, to prescriptions. Interesting on cigarettes, right, is inelastic. If we go over here to elastic, we can see air traffic, foreign travel, furniture, restaurant meals are highly elastic. And of course, we know the consequences of that, as I explained, i.e., on air travel, if we keep on increasing the price of airline tickets, guess what's going to happen to total revenues of the air industry is going to go down. Now, let's come down here. Let's look at an application now. Application and the formula, but let's get to the application first of all. Let's say gas prices in Phoenix jumped from $2.52 to $3.11 a gallon. This increase was due to a ruptured pipeline between Tucson and Phoenix. The pipeline normally bought 30% of Phoenix fuel from Texas. During this period, Phoenix gas stations could buy gas from West Coast refineries at a higher price. During this 3-week period of supply eruption, gas for gasoline sales quantity fell by 8%. And then I'm saying, okay, what is the price of elasticity of demand during this period? So this is the basic formula. Elasticity of demand, where we can quantify, we can determine what our coefficient happens to be, which is a percentage change in quantity divided by a percentage change in price. Well, in this particular example, or I should say the solution, we know that what? Sales quantity fell by 8%. So, in other words, 0.08, and we're going to divide that, and we're going to have to come up with a percentage change in price. Well, we know that the price went from $2.52 to $3.11, so we want to determine what's the percentage change. So $3.11 minus $2.52 divided by $2.52 in our denominator gives us 0.23. So we know that the change in quantity demanded fell by 8%, and the percentage change in price went up by 23%. So therefore, for the calculation, right, our elasticity of demand was 0.35, which is elastic. So once again, use this equation. Pretty straightforward for your assignment this week. And just kind of go back, as I said, kind of look at the notes I have here for elasticity of demand. And definitely look at page 115.